Okay, quadratic functions in vertex form. Remember that a quadratic equation in vertex form is in the form of y is equal to a, open bracket, x minus p, close bracket, squared plus q. So this should be in your note packages. Do you guys have this? This equation is on your formula sheet, so it doesn't need to be, you don't have to memorize it, but it won't tell you. You have to know that p comma q, that's the vertex of your function. So for this equation, or sorry, this parabola right here, the vertex, remember your vertex is either the highest point on your graph, it's either the maximum. So this vertex would be a max versus the other vertex would be a minimum. It's the lowest point on the graph. But once you get your vertex, so this vertex would be located at 4, 3, you put it into your quadratic equation. So this equation becomes y is equal to a. Is it going to be x minus 4 or x plus 4? It's going to be x minus 4, close bracket, squared, plus q. Plus 3. Okay, so from quadratic functions, the q value moves your graph up or down. That is called a vertical translation. So from 0, 0, where my vertex originally was, my vertex is going to go up 3 and to the right 4. So q is equal to 3. That is an up move. An up move is a vertical translation, 3 units, and then you tell me the direction, and the direction would be up. The p value, so it's not -4. P is equal to 4. That's going to move your graph left or right. That is a horizontal translation, 4 units, and then you say the direction, and this would be going right. The a value for this function, we know it's going to be a negative a value. So your a value tells you if your graph opens up or down. If a is less than 0, the graph opens down. And this one, a would be greater than 0, the graph will open up. In the next example, we'll calculate what the a value will be, because that's always a question every year you'll get on the exam. Remember that from these parabolas, we have an axis of symmetry, and we got an equation from that. So if I'm looking at this first one, the axis of symmetry divides your graph in half. It comes from the x value of your vertex. So the equation of the axis of symmetry for this graph would be x is equal to 4. And then the y value, what does the y value from the vertex give us? Does anybody remember what the y value does? The y value gives either the max or min of the graph. So the y value of this graph tells me that because this graph is opening down, it's a max. So there's a max at y is equal to 3. It's either the maximum or minimum point on your graph. And it's going to be used in your range. Okay? So let's quickly review domain and range for these, because again, domain and range is a question you'll always get, generally multiple choice. But for this blue graph, so we'll do the one where a is less than 0. All quadratics have the same domain, and the domain of quadratics are in interval notation, it's -infinity to infinity. Infinity is always rounded brackets. In set builder notation, it would be x is such that x belongs to the element of real numbers. So that would be your domain. Your range comes from that max or min. So this graph has a maximum of 3, and that's the biggest y value. The smallest y value is -infinity. So if I was doing interval notation, for this graph, the range would be negative infinity, comma 3, square bracket. In set builder notation, the range would be y is such that y is less than or equal to 3, comma yer. On your district exam, they generally have domain and range in the form of a multiple choice question, and they will mix up, like within a question, they'll include both interval and set builder notation. So you have to be able to know both. Okay. In 30-1, they almost, um, they, they primarily will use the interval, but on this exam, you're expected to know both. Okay, so for this question here, I'll do this one with you, and then I'll give you a couple that you could practice. Let's get this equation in vertex form. So y is equal to a, open bracket, x minus p, close bracket squared, plus q. The vertex is given, so 3, comma 1, and vertex is your p and your q. So y is equal to a, x minus 3, close bracket squared, plus 1. Okay, if you were asked the equation, oh, they have it for you here. Here's the equation of the axis of symmetry. So it comes from the x value of the vertex and the y value. This graph opens up. So there's a minimum value at y is equal to 1. That's going to have to give, that will give you the range of the graph. So the range of this graph, the smallest y value is 1, the biggest is infinity. That would be the range. Okay, in order to figure out your equation in vertex form, you first fill in your p and your q value, and then we're going to figure out our a value, and you're going to use a point for the a value. If you could use your y-intercept, that's the point I always choose. So in order to get my a value, I need to sub in a point, and the point that I'm going to substitute in is 0, 6. So x and y. So 6 is equal to a, 0 minus 3 squared plus 1. 6 is equal to a. Remember, this is negative 3 in a bracket squared, so be careful with that. Plus 1. 6 is equal to 9a plus 1. Subtract 1 from both sides. 5 is equal to 9a, and my a value is 5 over 9. So I go back up here, and I'll put 5 over 9 in. And the other thing I'm going to do is it says it wants a quadratic function in vertex form, and they give me the equation. So what you want to do is you want to match up your equation to what we've got. So I'm actually going to change y to f of x because they want it in function notation. So I'm going to change this to f of x. You would want to check on your calculator for this exam question that you got your everything correct. So how you would check that is you would go to y is equal to, and you would punch in your equation in y1. So I'm going to do open bracket, 5 divided by 9, close bracket. This is also very similar to something you're going to be doing in 30-1. So if you're good with this, you'll be doing it next semester. I don't really care what the graph looks like. Sometimes I don't even look at, I mean, I'll look at the graph, but then I go right to the table of values. And what I'm going to check for my table of values is 0, 6, which is right there. 3, 1 is right here. And they also gave me 6, 6 is right there. So I know that that would be correct. This question here, we will not do, but I have the note package scanned in and done. So this is a good question, but you could do that later when you're studying. And for this one as well. Just write here extra practice. These are really good because you'll be getting one of these questions, but these are writing, determine a quadratic function in vertex form for each graph. So it's asking y is equal to a, x minus p, close brackets, squared plus q. So I won't give you time right now to do it. You'll have time at the end of the lesson, and you could do these too. Okay, completing the square was big in quadratics. You will for sure get a completing the square question. So let's review a basic completing the square where your a value is a 1. Chances are you won't get an a value of 1. You'll get an a value other than 1. So let's review a basic one, and then we'll actually do these two. And then I will give you a different one to practice. Okay, so for a, y is equal to x squared plus 6x plus 5. So the reason why we complete the square is because this equation is right now in expanded form, or sometimes I'll call it standard form. And this equation doesn't tell me much. I could just tell from this equation that this graph is going to open up and the y-intercept. So those are two good things, that it's going to open up and the y-intercept. But if I can get this into vertex form, then I'll have the vertex, I'll have the y-intercept, and I'll be able to draw the graph, okay, if I wasn't able to use my calculator. So how we complete this square is you put your bracket around the first two terms, and you're going to rewrite it, and you're going to leave some space after this 6x. So y is equal to x squared plus 6x plus 5. Then what we did was we took that middle term and you divide the 6 by 2. So you divided that number by 2, the coefficient by 2, and you're going to get 3. When you square 3, you will get plus 9. And then remember what I've done is I've just added 9 to this equation. You can't just decide to add 9. You need to balance it by subtracting 9. And this is going to be our equation in vertex form, will be this guy here. I need an x in front of here. And then I need to figure out what my q value is. And my q value will be 5 minus 9, which is negative 4. This is my equation now in vertex form. Any completing the square question, you want to check on your calculators. So in order to check a completing the square question, in y1, you punch in the original equation in standard form or expanded form. So x squared plus 6x plus 5. Then you put what you think your answer is in vertex form. So open bracket, x plus 3, close bracket, squared, minus 4. If you get the exact same answer, you did it correctly. So the vertex of this graph, if I take out my p and my q value, my p value is negative 3 and my q value is negative 4, which makes sense. Remember we talked about like where did the student make a mistake? And they'll give you a whole bunch of lines and you're like, which line did the student make the mistake? And this might be like this line here. Well, did they make a mistake at this line? How you could check if there's a mistake made in this line is I could punch that into y3. And if it's the exact same graph, then no mistake was made, okay? So x squared plus 6x plus 9 plus 5 minus 9, right? No mistake was made in that line. So that's how, like, a good trick on if it's a question on where did the student make an error, and they give you, let's say, 4 different options. You just type each option into y1, y2, y3, y4, and the one that doesn't match up with this would be the mistake. Okay, and then at the end of the day, if this is actually in function notation to match it back up, so f of x. So for b, Y is equal to 3x squared minus 12x minus 9. Bracket goes around the first two terms. Then, when we go into vertex form, we have a 1 in front of that x. So right now, I have a 3 in front of it. So from these first two brackets, I want to factor out a 3. So y is equal to 3 x squared minus 4x, leave yourself some space, minus 9. This is my a value. My a value is going to be 3. Dividing this term is going to give me my p value. Okay, so to that negative 4, you take the negative 4 and you're going to divide it by 2. You're going to get negative 2. You're going to square it. Negative 2 is in a bracket squared. You always get a plus when we're at this step. We're going to get a plus 4 here. You can't just add 4 to an equation. You must balance it by subtracting 4. And I have to multiply that 4 by something. Angela, do you remember? By the 3. Yeah. So when we subtract, if we factor out an a value, we have to take care of that over here. So y is equal to 3. So there's my a value. The a value is the same. Graph opens up. Now I've got my p value, and this will give me my q value. So q value is negative 9 minus 4 times 3, negative 21. The vertex of this function is 2 comma negative 21. This graph opens up. It has a y-intercept of, oh, be careful. Some students will look at this and say the y-intercept is negative 21. The y-intercept is negative 9, right? That's the q value because this is in vertex form. Okay, try this one. So we don't have a constant, but that's fine. Brackets go around. Actually, we'll do this one together, and then you can do this one on your own. I'll give you a minute to do this one. Yep. Okay, so create your brackets. Get your a value outside. So divide each of those by negative 5. X squared negative 70 divided by negative 5 plus 14x. And leave yourself some space. Really, the c value is a plus 0. The y-intercept is 0 here. Take your middle term, divide it by 2 to get 7. There's my a value. Square it, and you'll get plus 49, and then subtract 49. And remember, you have to multiply that negative 49 by that negative 5 to give me plus 245. So a value doesn't change. It's still opening down, negative 5. My vertex, I could look at this and I could say I've got a vertex at negative 7, comma 245. Y-intercept was in this original equation. It was plus 0. So y-intercept was 0. Okay, I'll give you a minute. Do this one quickly. So y is equal to 4x squared minus 28x minus 23. To vertex form, it won't ask you to verify, but plug it into your calculator into y1 and y2, and you're going to graphically verify. There shouldn't be a fraction for this one. Is there? Oh, you're right, and I don't have this one. Oh yes, there will be a fraction for this one. Keep it in fraction form. The next one I'll give you for practice doesn't have a fraction. You're right. Okay. So when you divide negative 7 by 2, you would get this. Just divide it by 2. If this was a multiple choice question, they'd keep it in a fraction. And what you're going to do is you're going to square that. So you could plug that into your calculator, but I know that 7 squared is 49, and I know that 2 squared is 4. So I'd be getting 49 over 4, and then I'd be subtracting 49 over 4 times 4. Yes. Yep. And then you could borrow this. So this would be y is equal to x. So this 7 over 2 is negative 3.5, so I know the p-value is 3.5, so it's going to move 3.5 to the right. And then what are you getting for, well, this 4 over 4 will cancel, negative 72. And again, you would verify by punching in the original, then the vertex, and making sure that they match. This one, just write homework. This is no fractions for this one, so this should be a nice, easy one to do. And again, really, I would just want A. Can you put this into vertex form? Okay, so let's talk about equations. So if I give you f of x, 2x squared plus 2x minus 12, this is a quadratic function. It's written in function notation. So this guy, I know it's a, because my degree is 2. So that's a quadratic function. If I want to turn this into a quadratic equation, this is essentially, it is a quadratic equation, but an equation we're going to be solving, and we're going to be solving for the x-intercepts. So I'm going to let this equal 0 is equal to 2x squared plus 2x minus 12 equation. In order to solve quadratic equations, when we solve them, what we were doing this whole course when we were solving quadratic equations was getting the roots or the zeros or the x-intercepts, basically the same thing. So when we're solving, we're getting either, we can refer to as x-intercepts, the roots of the equation, or the zeros. And there was 4 different ways that we solved in this course. Graphing, throw this into your calculator, and then use the zero function on your calculator to get the zeros of the graph. Factoring, probably the least common is solve by completing the square. And then basically I always say if you can graph, you graph. Then between the, if it's algebraic, you try to factor first. If you can't factor, you're going to do the quadratic formula. So you're going to try this guy if you're doing algebraic, and then we'll jump to this guy. I will review how to solve by completing the square, but I would do the quadratic equation. Okay, so let's solve this one by factoring. First, we'd factor by a GCF. And I would get x squared plus x minus 6. Then the factoring becomes inspection, two terms that multiply to negative 6 and sum to 1. So it would be 2 and negative, no, it would be 3 and negative 2. Then you would set each factor equal to 0 and solve. You don't have to show that step. But if this factor here would give me a root or an x-intercept of negative 3. And this factor would give me a root or a 0 or an x-intercept of 2. Okay. Yes. Expanded form. Okay, so if you are in vertex form, let's say this guy here, to get back into expanded form, this would be y is equal to 3. That binomial squared means x minus 2, x minus 2, and then minus 21. So you're just expanding it out. Then I would deal with these two brackets next. So I'd say x squared minus 4x plus 4 minus 21. Then I would put the 3 in. 3x squared minus 12x plus 12 minus 21. And then you combine your c values. Yep, so that's how you would expand to get back. Okay, so that's what we're going to review now, because this was the second chapter. So the second chapter was solving. Remember the discriminant. So you're going to get a question, probably only one on the discriminant. It tends to be a multiple choice question. So let's review what the discriminant is. If you can't factor, you use what's called the quadratic equation. And the quadratic equation is on your formula sheet. But here's what the quadratic equation is. It's x is equal to negative b, and we'll do a question where we're using this just to make sure. Negative b plus or minus the square root, and I'm going to put this in red, b squared minus 4ac all over 2. This b squared minus 4ac, that was what was called the discriminant. Is the discriminant. Based on that number, whatever that number is, you can just look at the discriminant and you can tell one of three things. It's either going to have two x-intercepts, like this guy, or your quadratic will have no x-intercepts, or it will have one. Those are the only three scenarios with x-intercepts and quadratics. So how you are going to calculate that is you're going to figure out what the discriminant is. And that number is either going to be a number bigger than 0, less than 0, or equal to 0. If that number is greater than 0, so write that in this example here, can you take the square root of a number bigger than 0? So let's say the number is 25. Can I take the square root of 25? Yes. If you get a number greater than 0, your quadratic will have two x-intercepts. And remember we use like different, it says two real x-intercepts, right? So you use square root that's a real number. They're two real zeros distinct. They're two different x-intercepts. If you figure out what your discriminant is, And let's say you calculate that number and you get negative 49. So we get a number less than 0. Can you take the square root of negative 49? No. So if you're doing your, let's say you get negative 8 plus or minus the square root of negative 49 all over 2. If I give you this and I say, what are the x-intercepts? You can't punch that into your calculator. It won't work. It's going to give you an error. There are no x-intercepts. So this would be no x-intercepts. And then the third option is you could calculate your discriminant and it's going to be exactly 0. That means that your quadratic equation had one x-intercept. And it's going to be something like in this form. Like let's say that was 5. It would be x minus 5 close brackets squared. There's two factors there, x minus 5 and x minus 5. But what's the x-intercept? It's 5, right? There's one x-intercept. So that's what the discriminant does. And again, you will get a question on the discriminant. So I'll try to assign some. Actually, I'll show you. Let's do, there is a discriminant question that I have in here. We're going to come back to this because we have to go through the factoring, which you'll need to know. But let's go to this one, the quadratic formula. Okay, so without even graphing these, we'll be able to figure out just by calculating the discriminant which one of these is going to have two x-intercepts, which is going to have one x-intercept, and which will have none. So what we need to do is you need to write your a value, your b value, and your c value. So this first equation, a is negative 2, b is 3, c is 8. The discriminant is b squared minus 4ac. So 3 squared minus 4, a is negative 2, c is 8. Could somebody calculate what that discriminant would be? Izzy, do you have it? Isaiah, do you have it? 73. Somebody confirm that they're getting 73. Okay. So this discriminant is 73. Basically, underneath the square root sign, we would have a 73. If I ask you what the discriminant is, it is 73. It's not the square root of 73, it's 73, but it would be under the square root sign. Then you say to yourself, is that a number bigger than 0, less than 0, equal to 0? I know that's bigger than 0. I could take the square root of 73. It'd be an irrational number, but it doesn't matter. That means that this graph has how many x-intercepts? 2 x-intercepts. So this graph has two distinct just means different roots. The roots are real because you could take the square root of that number. Look at B. A is 3. B is negative 5. Does anybody know what C is? It's 9. You would rewrite this because you want it to be equal to 0, right? Your quadratic equation, it's x squared, like everything is equal to 0. So bring that 9 to the left. Okay, calculate your discriminant for B. So b squared minus 4ac. Negative 5 in a bracket squared will give you 25 minus 4 times 3 times 9. It's going to be a negative number, it looks like. Steve, what are you getting? Negative 83. That number is the discriminant. It's always underneath, though, in the quadratic formula, the square root sign. The discriminant, though, is negative 83. That's less than 0. I can't take the square root of a negative number. So this graph is going to have no real roots. it's going to look something like this. It's going to have a y-intercept of 9, but it's going to look something like that. For C, calculate what your discriminant is for C. So b squared, so -3 squared minus 4, a is 1/4 and c is 9. This will be the 0, right? 4 over 4 will cancel. -3 is 9. -3 squared is 9 minus 9. Yeah, I'm getting 0. This guy will have 1 root. Okay, it could be said there's going to be one x-intercept, or they might say this. We use this terminology when we were on our test, 2 equal roots. Because remember, this graph, if it has one x-intercept, it's going to look something like this. So that's one root, one x-intercept. Or let's say that was 6. It's x minus 6 squared. So the reason why it says 2 equal roots is because there's 2 factors, x minus 6 and x minus 6. The x-intercept is minus 6 twice, basically. Or sorry, x is equal to 6 twice. Okay, let's go back to the factoring. You will not get an A on your test. That's a 10C question. GCF, and then it's an inspection question. You will see one of these on your test. Remember these? This was a special factoring. So let's review how we did this. It's going to be a factor question. And you're going to say to yourself, okay, factoring I know is a GCF, or it's an inspection, a decomp, or a difference of squares. And then you're going to see all these brackets and say, okay, wait a second. Like, why is there so many brackets if we're factoring? This was like a special factoring. So if you look at these brackets, they're the same for A. So off to the side, I'm just going to say let, and I'm going to pick a variable other than A. Sorry, other than x plus 2. X plus 2 and x plus 2. I'm going to pick A. So I'm going to take out that bracket, and I'm going to put in, whenever I see an x plus 2, I'm going to put in an A. So I will have 12a squared plus 24a plus 9. Now, all of a sudden, it looks like the factoring we're used to. And this would be, I want it to be an inspection. I can't get rid of the 12, so it's going to be a decomp. But what is the GCF? Yeah, let's take out a 3 first. And I would get 4a squared plus 8a plus 3. It's a PSA 2 or a decomp question. You're looking for two numbers that multiply to 12 and sum to 8. Ailey, what would my two numbers be? Two numbers that multiply to 2 and 6. It's decomp. The first number is a 4. I'm going to put the 2 next to it. So how do you decompose 8a? It's 2a plus 6a. Bring down your plus 3 and your 4a squared. Split it in half and group factor. So from these first two terms, I could factor out a 2a and I'd get 2a plus 1. From the second two terms, I could take a factor out of positive 3 and I would get 2a plus 1. These two are the same. So one of my factors is 2a plus 1. One of my factors is 2a plus 3. Don't forget this. GCF. And then at the end, you need to go back and you need to take your A's out and put what A was equal to. So A was x plus 2. So it's going to be 3, 2, x plus 2 plus 1, 2, x plus 2 plus 3. So I'm going to get a 3. This will give me 2x plus 4. Okay, so we should be getting, oh no, that should be a plus 1. 2x plus 5 should be one of your factors. And 2x plus 7 and 3. Those are your 3 factors for this. Okay? Maybe you won't see the brackets are the same. Maybe the brackets will be different. So don't panic if they're different. Just take that first bracket and we'll call that one A. Then take the second bracket and we'll call that B. Rewrite it with your A and your B's, and then you should recognize what type of factoring it's going to be. So it will be 9 A squared minus 4B squared. Rana, what type of factoring would that be? Two terms separated by a minus. Any idea? Brooke? Difference of squares. Two terms separated by a minus is a difference of squares. 3A minus 2B, 3A plus 2B. Then you're doing quite a bit of work to each factor to figure it out, right? You'd have 3 2t plus 1 minus 2s minus 2. So just be, if they gave you a question like this, just be very careful. A is 2t plus 1 plus 2b is s minus 2. I'll tell you what I got. I'll give you a minute to see if you could get it, and then I'll tell you what I got. So distribute in the 3, then distribute in the negative 2. Combine your like terms. Distribute in the 3, distribute in the positive 2. Raise your hand if you finish this one. I just want to see how many people think they have the 2 factors. 6t minus 2s. Okay, so I got that one. 6t minus 2s plus 7. Angelo? Yeah, these are the two I got. 6t plus 2s minus 1. You'll show her yours, Izzy. Okay. Okay. Um, let's look at C. Yep, that's fully factored. Then you would look and you would just say, is there a GCF from either of these brackets? But there's not. Okay. What would C be? What type of factoring would that be? Two terms? It's a difference of squares. Yeah. So let's figure out what this is. Let's do C together. This one's easy. The square root of 9x squared is 3x. And then the second one is the square root of, well, I know the square root of 64 is 8. So the square root of 0.64, move your decimal, is 0.8. And then we got a y squared. Square root of y squared is y. So plus 0.8y minus 0.8y. Do you remember how to do fractions? So this was C. Let's do B really quickly. 1 over 4 x squared minus x minus 3. What am I factoring out? What's my GCF? How do I get my a value to be a 1? What do I divide out? Get rid of that quarter, right? 0.25, get rid of it. Let's factor out 1 over 4. So that's a GCF. GCF out to 1 over 4. A quarter divided by a quarter is 1x squared. This is going to be an inspection question. Negative 1 divided by 1 over 4 is the same thing as negative 1 times the reciprocal, 4 over 1. So that would be negative 4x. Negative 3 divided by this is the same thing as negative 3 times the reciprocal. So negative 3 times 4 is negative 12. Yes. Yes, let me talk about that in just 1 second. Okay. And then from here, you're going to get 1 over 4. There's an issue with that, though, that I'll show you. X minus 6 and x plus 2. Those would be your factors. That would be my fully factored answer. If they said solve, I'd then let it equal to 0, and my x-intercepts would be 6 and negative 2. Okay, so what Ailey had said is he said, could you multiply this entire equation by 4? And you would get x squared minus 4x minus 12. So I just want to show you. He would get it right, but he'd be missing one thing if he did this. Okay, so I'd get this, and then I would factor by inspection, and I would get that x minus 6, x plus 2. What would my factored answer be missing? The 1 over 4. So here's what you have to say to yourself. You just multiply this equation by 4. You changed it. You multiplied it by 4. So to balance that, you divide by 4, which is where the 1 out of 4 comes from. So I would just divide out that fraction is how I personally would do it. Yes. No, because this question, if you look at it, it said factor. So if I was boxing this in, it would be that. If the question said solve, I would say this is equal to 0. And then I would say my solution would be x is equal to 6 and negative 2. Solving is giving the x. Okay. Okay. Let's do this question. I'm going to show you how to solve by completing the square. I don't know if you'll see it. You're going to see completing the square, but chances are you're not going to see solving. But let's do it just in case it ever was on an exam. Rewrite this. Is when we solve, we could do the quadratic formula or factor, or we could type it into our calculator, but we have to have 0 on one side. I want my x squared to be positive when I'm solving. So I'm going to have x squared plus 10x minus 21 is equal to 0. Now, can this question be factored? Is this factorable? Can't be factored. So we've got two ways that we could solve this. Quadratic form graphing. Okay, so remember you always graph first. Graph and get the x-intercepts. So let's actually do that because then we're going to verify everything on our calculator anyways. Okay, so in y1, so let's review that we could actually graph this. X squared plus 10x minus 21. Okay, I've got two solutions. I could tell right now that they are, I'm going to look for the zeros. Did I not put the 10x? Cute. There's one. The other one, it looks like it's going to be over here. So I'm going to change my window. I'm going to go to minus 20. And my minimum, I'm going to go down to like minus 20. Let's just see if you could see this a bit better. Okay. So let's get that x-intercept. Second, calculate 0. Here's where this is showing you where your cursor is. It's at -5, so it's down here. So I'm going to do my right arrow until it comes onto my screen. Okay, I want that 0, so I'm going to do left bound, and I'm going to do right bound. Okay, so this is not going to be factorable, right? So one of my x-intercepts, it says nearest 10th is 1.8. So we'll get the answer before we do any type of work. The other x-intercept, you want to find that x-intercept, go left first, and then right. Okay, negative 11.8 will be my answer. Now, because we can't factor, we could either do the quadratic formula or we can complete the square. So let's actually do both to make sure that you know how to do both. Though out of these two, I would do quadratic formula. But let's do both. So x is equal to negative b. So negative, this is my b value. So negative 10 plus or minus the square root of b squared minus a is 1 and c is negative 21. All over 2a. Sorry, a is 1. X is equal to negative 10 plus or minus. Gabe, do you have what the discriminant is? No, not square rooted. What's the discriminant? 184. Somebody confirm. Is that what you're getting? So 10 squared minus 4. Yeah. Okay. all over 2. What would you do to that square root of 184? If they wanted the x-intercepts, let's say they didn't want any rounded answer, but simplified, what would you do? Yep, you would, so let's actually reduce it. So just off to the side, 184 divided by 2 is 92, divided by 2 is 46, divided by 2 is 23, and is 23 prime? So we would stop. So we'd get x is equal to negative 10 plus or minus. This would be 2 root 46 all over 2. Can I clean it up? Yep. I could divide everything by what number? By 2. 2 goes into 2 once. It goes into 2 once. 2 goes into negative 10. This would be 5. So my answers are going to be negative 5 plus or minus the square root of 46. That's an exact form. So then I'm going to go to my calculator and I'm going to double check because I know these x-intercepts, right? I know that they're 1.8 and negative 11.8. So it should be these two numbers. So negative 5 plus the square root of 46. There's the 1.8. And negative 5 minus the square root of 46 is the negative 11.8. Okay, let's complete the square. How would you solve this by completing the square? So write out your equation. Put a bracket around the first two terms. Rewrite it. Give yourself some space, like we've always been doing. So x squared plus 10x, and then just put that equal to 0 over here. Take that 10, divide it by 2. And we're going to get plus 25, and then you're going to minus 25. So basically, I'm putting it into vertex form first. Negative 21 minus 25 is negative 46 is equal to 0. You guys, look at what we know the answer is. Square root of 46, and there's a negative 5. Do you know what I would do from here? If I was solving, it goes to the square root principle at this step. Do you remember the square root principle? We want to solve from this step. So we want to get this by itself, right? So get rid of that negative 46 by adding 46. So bring 46 to the right. Then you say you square root both sides. Yep. And when you square root both sides, you're left with x plus 5 is equal to plus or minus root 46. And then you bring that 5 over. And that's how you do that. I find more people, though, will make a mistake completing the square, solving by completing the square, than they will on the quadratic formula. Yes. Okay. And that is it for, that was 2 units. So I'll give you some homework questions. You guys find this one, this golf ball question. Make sure you're able to do this one because you will probably have some sort of a word problem like this where you're graphing it and be able to find your vertex on your calculator, the x-intercept on the calculator. Remember that if this is a golf ball question, so what's happening, I could tell that the y-intercepts are 0 here. So you're going to hit a golf ball right from the ground. It's going to hit its max height. And then this is when the golf ball will hit the ground right there. Remember though, if you're doing the range of this on a test, you're doing a real life scenario, you would need the max height that the golf ball travels. And what would the smallest 0, the range, right? The domain would be from 0 to wherever it lands, things like that.